Hello there and welcome everybody to this tutorial video about wireless redstone using water updates in Minecraft version 1.16.4. Wireless redstone using water updates was originally presented by XCOM 6000 and Earth Computer of the SciCraft server. Go check out the videos to wireless redstone using water updates, and also there's a video from SNAS on YouTube who showed a simple version of a teleport system using this 20-channel encoder, this antenna, and a receiver circuit with ender stasis chamber, which is a very, very useful application for wireless redstone, as you see it before you right here. Now I will quickly go over the mechanics of wireless redstone and how to build transmitters and receivers. So with water-based wireless redstone, we use the fact that Minecraft can only handle 65,500 water updates every game tick. So if we were to create that amount of water updates, which this antenna is for right here, and at the same time check whether water is flowing, it will no longer flow because all the water updates are exceeded for this game tick. I can quickly demonstrate that right here. If I just fire the circuit right here to your left, you can see the water flows down and creates a short light pulse right here. And if at the same time I now fire these pistons in the back, you can see that the water did affect them. Oh, that lagged a lot. Let's try that once more. Right there, there was no light. Okay. Now, to make this applicable anywhere in the world, we'll have to time transmitter and receiver circuits to one another, so that the receiver checks if at a certain game tick the water is not flowing, and the transmitter knows at what game tick to send the signal or to block the water updates. And what we can use is daylight sensor, because with these, the red little circuit right here is a globally synchronized clock. With a globally synchronized clock, we can say, okay, we have a window between each clock update, which is 20 game ticks, and in every game tick in this window is a slot to use as a frequency. And if we say we use we just label one of these game ticks in the window as frequency 1, and at the same time we're checking for water flow and we're blocking the water flow, then that can be interpreted as a signal being sent from the transmitter. As opposed to if the water can just flow, that's a normal state, as you can see right here. We have such a circuit. This one is always dispensing water and it's always flowing down. And if we now block it, the water updates at this specific time slot, you can see right here we get an output from the circuit. All of this is unknown stuff, which you can also check out SNAS's video for, where we will explain a few things in detail. Just to know, that's how the circuit works. Globally synchronized clock, a delay to select which time slot we use, and this flow checker. And if the flow is inhibited, then we get an output signal. The blue stuff in the middle here is the hard-coded delay, which, as I said, is specifying which time slot we use. And these are all the delays that you can build in there from 1 to 20, and always with an increment of 1 game tick, which is and so 1 redstone tick is 2 game ticks. So always 2 steps is 1 redstone tick, and 1 step is 1 game tick. And we have to use scaffold updates because scaffold updates can get us to the odd frequencies because they take only 1 game tick and break out of the bonds of regular redstone updates. By using all of this, we can make this circuit a little bit smaller, which you can see right here, which is just a little bit wrapped together. We still have the same components, globally synchronized clock in red, the delay in blue, and all the possible delays that you can use, and the water flow checker right here. This is currently turned off because it gets on my nerves, but you get the idea. And also, if you really like, we can also make this one white and tileable, which you can see right here. We still have the globally synchronized clock, some delay, and this is the flow checker tileable. And at the end, we have an output signal. And using this, we can make a receiver that can check for multiple frequencies at the same time, or every clock tick. So right here in the end, we can see this is frequency 8. So let's go to the encoder and try to send a signal on frequency 8 right here. And if we fly back, you should see turn on frequency 8. Yeah, pause the video if you want to know how to build this. One thing, which is fly right here, you can quickly pause. And one thing we use is also the scaffolding update trick. So there's a scaffold, and below the scaffold, we open the trapdoor so the scaffold gets the bottom, and that takes 1 game tick to update, which this observer will see 1 game tick. So from this observer to this observer will 1 game tick, simply because the scaffold did update. All adjacent scaffolds, they will also update. So this will update first, and 1 game tick later this. So we have 0 ticks today, 1 game tick, 2 game ticks, 3 game ticks, 4 game ticks, 5 game ticks, and then 6 game ticks. Half of that is 3, so 3 redstone ticks. So we can start anew with the whole thing and tie it to one another. And that's the same way this encoder works. We push a button and start giving let the globally synchronized clock give us a pulse, and the pulse will trigger all of these observers 1 game tick after another, and on that frequency where we push the button, the block will get pushed down and it will be transmitted to this side over here, conditioned to make 2 pulses and then pulse the Untitled Chapter. And that's how the encoder works. And the smaller 10-channel encoder works the same way, but you don't use all the game ticks, just the redstone ticks. So from one to the next observer firing is just 1 game redstone tick, and we can achieve that by just using regular redstone repeaters, or you can also place observers right here. That's the basics of receivers and transmitters for wireless redstone. And one neat addition that I made to this repertoire of machinery is the Get Me Home circuit. It's a circuit which you can build up anywhere in your world. It's this thing right here that you can activate, and if you activate it and you have your transmitter checking, then the transmitter will see that you have indeed activated this machine, and it will teleport you home using an endopus stasis chamber. The way this circuit works is that we have this antenna which exceeds the water block limit, and what we do is we take out 1 piston in the back. Let me destroy 1 redstone here, and as you can see, the piston gets moved out of the way. If we now use our regular receivers, they will no longer function. Let's test this one. There should be no signal received right here. As you can see, no signal received. And so if we tear out a part of the antenna, the receivers will no longer work. But if we build up this thing right here, which I call the missing piece circuit, the antenna will start to work again, and that we can check for. So if I turn it on, Now, where were we? I was explaining that this will complete the antenna, and right now all the receiver circuits that are correctly timed with this missing piece circuit, they will work. Which is, for example, this one right here. It's the same receiver as over there, but as you can see at the delay right here, it's tuned to frequency 1, and this one is also tuned to frequency 1. So if we set our frequency 1, we should see that we get a signal over there. And as opposed to if we don't use the missing piece circuit, let's turn it off, and now use frequency 1, we should not get a signal. And there we have it. There was no signal received. And we can use this to let ourselves be teleported home from anywhere in the world. And the way we would do that is, right now I'm turning it on with the lever, but if you use it, you just stand on this pressure plate so that if you get teleported away, the whole circuit stops working. Let's just use it as is right now. And what you would do is you would have this circuit right here. And what it does is once every day, it checks 5 times whether this thing is working. And if 5 times it says, yes, okay, the missing piece circuit is built, the antenna works, and the receiver is receiving a signal. If that happens 5 times, it will be interpreted as, please get me home. Now I really suck at throwing these ender pearls. Please stay. Please stay. There we go. Okay. So let's try that out. This circuit right here will, well, the outlined piece right here, that's just a receiver on frequency 1, just as the missing piece circuit. And the rest is just creating 5 pulses on frequency 1 to check whether it's functioning. And ideally, you just have it being controlled by this daylight sensor, which starts this machine once every day. I'm going to use manually right now. So as you can see, start moving, and this receiver is indeed receiving signals. And after it has received 5 signals, it will decide, okay, this is a home signal, and it will turn on this ender pearl station. And there we go. And after this will turn off, the trapdoor closes, and I will get teleported there. Let's just wait 1 second. There we go. Okay, and now we've been teleported home, which is quite neat. The materials for this is not a lot, as it's all that you can see in front of you, not much, and it all fits in one shulker box, and the shulker box you can put into your ender chest and take it with you anywhere you go. And if you get lost for some reason, which shouldn't happen really, you can build it and teleport home as long as the antenna is chunk loaded. Yeah, all the machinery you can look at yourself. I will put a world download in the description. There's also a mock-up of how the transmitter is timed, and you can build any part of the machinery that you would like. You can just build the encoder here and not worry about any of the purple part of this little 10-channel encoder. You can just build what you like. Down here, this is a smaller compacted version of the receiver, and the delays corresponding to it. You can use that to build your wireless redstone. But keep in mind, this is quite a big thing, so it's rather in the end game genre of machinery. And if you don't want to have an ugly, huge pillar of water, then you can also expand this further to the back, not to the side because of the rails, but further to the back, and make it so it's not that high, and put water blocks next to it and the chunk next to it, or over 3 chunks, then it's even lower, then it's only 86 blocks high, which you can hide beneath the surface. Yeah. One more thing, the way the home circuit works is that you will have to punch out pistons and observers down here until the machine stops working, and so that you have only one piston that you have to pull out in order to make it work again. And you'll have to figure that out where the point of that happening is. It might be different if you do not have the exact same water pillar that I have right here. So, as I said in the beginning, check out XCOM 6000 and Computer, their video on water-based Redstone and especially SNAS. We built a teleport system that you can see right here, and I rebuilt with my design for the receiver, and Ilmango's chunk loader, because indeed it has to be chunk loaded to receive any signals, which would be the go-to application of the system. Just push one button and get teleported to the station. Check out SNAS's video in the description. Yeah, have fun building, and if there's there are any updates, then I might do a second video. Cheers and goodbye.